Hi, and welcome to the 29th session of Physics 9. This is Sir CJ, and I think that you still remember that in the 28th session, ang finocus natin doon was gravitational potential energy. It was the first potential energy type that we have in this catalog, and in this session, we are going to focus naman on the second and so far last type of potential energy that we're going to discuss in these sessions, which is elastic potential energy. And then it's gonna be followed by a mathematical discussion through a sample problem on elastic potential energy through a guided sample and problem solving activity. As usual, I think you already saw our pattern, right? So first, ang gagawin natin is we're gonna be guiding each other in solving the problem, showing you the formulas, what to do, 'di ba? And then parang introducing some new concepts kung meron mang bago, right? Ayan. And then after that, ang ginagawa natin is you will be on your own. So after the guided problem-solving activity, you will be on your own through an independent problem-solving activity. All right. Now, the purpose of all of these parts of this session is to bring you closer towards becoming better at explaining energy transformation that happens in various activities or events, such as in waterfalls, in archery, as well as amusement rides. So remember that these sessions and these parts of these sessions are actually based on the 7E based self learning module in Science 9, which I wrote for my master's degree. And then you'll be finding it particularly in Unit 4, book number 21, pages 15 to 18. Yeah, let's start. Now, you remember that in gravitational potential energy, ang mahalaga doon was yung position, right? Kung nasaan yung bagay relative to the center of gravity in the planet, right? This time, we're going to look at potential energy of an object based on its configuration or structure. Some objects are just made to have elastic potential energy. Now, made, ibig sabihin, this type of potential energy, you won't really see it in just any kind of material. Okay, there are specific kinds of objects that possess elastic potential energy. Hindi siya makikita sa lahat ng mga materials that you may want to name. Okay? Now, if halimbawa, you think about the word elasticity, I think that the one of the first things that will come to mind is yung rubber band, right? There was actually a time in our lives or in our generations na ang tawag ng mga matatanda or maybe other dialects in our country, they still call it like this. Ang tawag nila sa rubber band, pwedeng goma, pero they also call it lastico, right? It's because maybe it's very much close. It's very close to the concept of elasticity. Kaya lastico ang tawag nila. Have you tried using a rubber band, or have you also tried using, or dealing, or playing with a spring? Yeah. When you try pulling the ends of a rubber band, or maybe not really ends, when you pull the ends of a spring, the springs that are shown in the previous figures, actually hindi to figure number 139, pero I think you already get what I'm trying to say, right? Halimbawa, in figure 40, you pull the ends of these springs. You will feel a force, right? And this is much like the kind of force that is resisting yung application of force mo, which is yung pulling it apart. Now, there is a force that you will feel when you pull the rubber band, and when you pull the the ends of a spring far from each other. And then when you release it, they go back to their original sizes and shapes. Ayan. So, what do you think is happening there? Why is there a force? Okay. Now, once you release it, it goes back to to its original form. What does that mean? Is it elastic? Or is it flexible? Remember that in Science 5, I think, yeah, it was Science 5, elasticity and flexibility are two different things. If something could be bent, then it's flexible. But if that something could be given pressure, and then after the application of pressure, it returns to its original size, its original shape, then we can say that it's elastic, right? Ayun. So, I hope that we clarify in this discussion that there are things that have an elastic potential energy and things that don't have elastic potential energy. They're simply no, flexible, pero they're not really elastic. Okay? And yeah, what more, kung di flexible yung bagay, we can therefore conclude that it's really not possessing elastic potential energy. Now, that is elastic potential energy as a concept explained in words. But mathematically, it could be explained as the following. It is the product of the force constant or the spring constant of a particular spring, which is usually given. Okay, pero sometimes you can still, solve for it given this kind of formula. Okay, and then it is multiplied by the elongation or compression of the rubber band or string, and this is expressed in meters. Okay, and then you're gonna be squaring that. It's a square that you're gonna be multiplying to the force constant, and then you're gonna be dividing that by 2. Now in symbols, it's gonna be PE elastic or PE small letter e is equal to kx squared divided by 2. The elastic potential energy of an object is equal to the product of the force constant of the object in Newton over meter. So it has to be noted na hindi yan Newton meter ha. So it's Newton over meter. And the elongation or compression of the rubber band or string, remember, in meters divided by 2. And yeah, do not forget you have to square it up. Okay? Alright. The force constant of an object, in this case of an elastic object, is the amount of force needed to produce an elongation of compression in a spring or rubber. You call that force constant. Yung amount of force na kakailanganin mo para ma-bend, para hindi ma-bend actually, para ma-elongate mo siya. Yun yung force constant. Now, a rubber or spring that has high force constant means that it is difficult to stretch or compress. 'Di ba may mga ganun, may mga rubber bands na parang mahirap silang i-stretch, 'di ba? Tapos meron ding mga springs naman na parang ganun din, mahirap silang ma-stretch, mahirap din silang i-compress. That means mataas ang kanilang force constant. Now, the force constant is derived using the following formula. So, if halimbawa hindi given yung K, you can solve for it. Okay, so it's just actually the kumbaga quotient between the force and the elongation or the compression of the rubber band spring. So halimbawa you apply the particular amount of force in Newton, and that force elongated or compressed the rubber band or spring in meters. Okay, so again, this is in newtons, this one's in meters. You're gonna get the force constant. And yeah, the unit you're gonna be getting is gonna be Newton over meter. Ayan. So, I hope that or I gave you everything that you need to know so far about the physical nature, the concept of elastic potential energy, as well as its mathematical explanations. Now, let us move forward to the guided, I'm sorry, hindi pa independent to the guided problem-solving activity on elastic potential energy. Let's say that a spring is stretched by 0.09 meters by a force of 450 newtons. Okay, so inelongate siya and it reached 0.09 meters. Now, the question is, what is the force constant of the spring? What will be the force that will elongate the spring by 0.18 hundredths meters? And how much elastic potential energy does the spring has? So the first answer will be in Newton meters. The second answer will be in newtons. And then the last answer will be in Newton meters. Okay, so remember, Newton over meter and Newton meters are different. Let me correct what I said if ever man nagkamali ako doon. No, so just remember, the first one is gonna be Newton over meter. The second will be in Newton. And then the last one will be in Newton meters. Now, the givens are the following. The force that was applied was 450 newtons and it was capable of stretching it. So that's the first stretch, X, by 0.09 meters. And then meron siyang second question dito. So X sub 2 will be the 0.18 meters. And then K is unknown. The second force in letter B is also unknown. And then the elastic potential energy, yes, is also unknown. So we're gonna be solving for 3 different factors in this formula. And we start with, of course, the first one, the force constant. So to get the force constant, you just have to recall the formula that I gave you in the discussion, and it is K is equal to F divided by X. So given ng F, given din naman ng X sub 1, actually we're gonna be using here X sub 1, 0.09 meters. Okay, so first, substitute the givens. Can you do it? Okay, does it look like this? If it does, then you're doing a great work. Now you're gonna be carrying out the operations. What are you gonna get? Alright, you're gonna be getting 5,000 Newton over meter. Please, okay? Wag kang nang malilito sa ating mga units, okay? Alright. Now, the second thing we're gonna be solving for will be the force if we have a new X or a new stretching distance. Dati 0.09 meters lang. What if ngayon it's 0.18 meters na siya? Gaano karaming force ang, kumbaga, kailangan to stretch it like that? So, kung dati 450 will result to 0.09, ano naman ang force na kailangan kung ang result mo is 0.18 meters? So yeah, we're gonna be using the following formula. It's actually similar to the first formula in the first force constant. It's just that this time, ang unknown natin is going to be the force. So what are you gonna do? Okay, first is cross multiply and then divide both sides by... Okay, you're gonna be dividing both sides by... Okay, I hope that you know how to derive a formula as of now, no? Okay. Baka kasi magtanong ka kung bakit siya naging ganyan. Okay, do you divide both sides by something, by anything? Okay, you're not gonna be doing that because by cross multiplying, you already have a formula for force. Okay, it's gonna be force is equal to the force constant multiplied by the distance that it was stretched. Okay, now that you have this formula, you're gonna be substituting the given factors. So what is going to be what are going to be your given factors? How will it look like? Does it look like this? Alright, you're gonna be multiplying 5,000 Newton over meter by 0.18 meters. Then, yeah, carry out the operations. What did you get? Okay, so force 2, it's gonna be 900 newtons. It's actually making sense, right? Kasi you doubled the distance na dapat ma-stretch siya. So, kung dati 450, then dapat ngayon, madodouble din siya. It's gonna be 900. Okay, so it's gonna be 900. It's gonna need 900 newtons para ma-stretch siya ng doble dun sa initial na pagkaka-stretch sa kanya. Alright. We're done with the second requirement. Let's now look at the last requirement and compute for the elastic potential energy that the spring has. So to do this, what we're gonna be doing is we'll be using the following formula. So PEE is equal to kx squared over 2. And then you're gonna be substituting the given factors. Now, you notice that we are no longer using 0.09 dahil we changed already the conditions in letter B. Okay, we already changed the conditions. All right, so now that you have these substituted, please carry out the operations. So first, you square this, you multiply it by that, and then you're gonna be dividing it by 2. What did you get? Okay, I hope that it looks like the following. You got 81 Newton meters worth of potential energy. So what happened here was you multiplied Newton by meter squared. So it's gonna be Newton meter squared. And you multiplied M by 1. So it's gonna be just M. Right? And then since may M ka sa baba at may M squared ka sa taas, you're gonna be canceling one of the M's in the M squared. Magre-remain yung isang meter in the numerator, and then yung M naman na nasa denominator is gonna be fully removed. Okay, kaya wala na siyang meter dito. Alright, so this is the result of the solutions that we have for this guided sample problem activity. So I hope that in solving this activity, you took note of every single small thing na very important about solving problems on elastic potential energy, because right now you're gonna be solving your own problem on elastic potential energy. Are you ready? Okay, I hope you are. Now pull out an extra clean sheet of paper and solve for the following problem. By how much will a spring elongate if only 375 newtons of force is applied to it? Now, if it has a spring constant of 525 newton meters, what will be its elastic potential energy? So go ahead and list down your givens. Do not forget to label them properly with the units and identify your unknown. Okay? Okay, and then if you need this reminder, please label your solutions, start with the base form of the formula, and make sure that you box your final answers. Okay? Okay, so are you done? You can pause this video if you want to. Are you done? Okay, so the answers to these questions are the following. So the spring will elongate at 0.714 meters with an elastic potential energy of 133.821 Newton meter. And that caps this session. Alright, so I hope that you learned so much about elastic potential energy, and I understand it's actually a lot more complicated by than gravitational potential energy. But I am hoping that with this video lesson, you have started to understand the concept of springs and rubber bands in terms of their elastic potential energy. And that you know as well, or you have a basic understanding of how to solve problems related to elastic potential energy through the guided sample problem solving and the independent problem solving activities that we did in this session. Remember that this session aims at training you to become better at explaining energy transformation in various activities or events, such as in waterfalls, in archery, and in amusement rides. This is based on the 7E-based self-learning module in Science 9 that I wrote, particularly in Unit 4, Book 21, pages 15 to 18. I am Sir CJ, and I hope that I will see you in the next video lesson related to this topic. Have a good day.